Hello, in this lesson we'll look at how to write chemical formula for ionic compounds. Now, what is ionic compound? Ionic compound is compound formed between a metal and a non-metal. Okay, I repeat, is a compound formed between a metal and a non-metal. Now, what are the metals? The metals are on the left hand side of the periodic table. So this is a copy of the periodic table. Okay, there is a staircase here. So everything to the left hand side of the staircase are metals. So all these are actually metals. And all the elements to the right hand side of the periodic table, to the right hand side of the staircase, are basically non-metal. So an ionic compound basically is a compound formed between a metal, left hand side of the periodic table, and a non-metal, right hand side of the periodic table. Now let's take a look at an example. Now an example is, the first example would be potassium chloride. Now, how do you write a formula of potassium chloride? Now, potassium, if you look at the periodic table, potassium is right here. Okay, so the chemical symbol is K. And chloride is actually from the word chlorine. And chlorine, it's right here, it is Cl. Now, in order to write the chemical formula for this ionic compound, a metal named potassium and a non-metal named chloride, the first thing is you need to figure out the charge of the potassium and the chloride ion. Now, what is the charge of potassium ion? Now, if you look at the periodic table, the potassium is in group 1. Okay, group 1. Group 1 means 1 valence electron. So all the elements in group 1, they have 1 valence electron. 1 valence electron means that the element would tend to lose the electron in order to be stable. And when potassium loses the 1 valence electron, it will become a positively charged ion. So the positively charged ion is called potassium ion. And your potassium ion would have a charge of positive, 1 positive. So all the elements in group 1 would tend to lose 1 valence electron to become an ion with a charge of 1 plus. So you can actually write in your periodic table at the top of group 1 as 1 plus. This is the charge of the ions formed by the group 1 elements. So likewise for group 2 elements, group 2 means 2 valence electron. In order for the group 2 elements to be stable, it will tend to lose the 2 valence electron to become an ion with the charge of 2 plus. So you can actually write a 2 plus at the top of group 2 in your periodic table. Likewise for the other groups. Okay, for example, for group 7 means all the elements in group 7 would have 7 valence electron. 7 valence electron means that it would tend to gain an extra electron in order to be stable. So when an element gains 1 electron, it will become negatively charged ion. So you can actually write at the top there -1. Okay, so in this case, chlorine, the charge should be -1. Potassium, the potassium ion, the charge should be +1. So you can actually write here plus and minus. And then after you have got the formula of the ion, you can actually ask yourself, how can K plus That means when K plus and Cl minus join together, what happened to them in order for them to be stable? 1 plus 1 negative, so they will cancel off each other. Therefore, the formula for potassium chloride is just KCl. Alternatively, you can use a cross multiply. Okay, this is 1 plus, this is 1 minus. You can actually cross multiply. The 1 here would become the subscript of the Cl, and the 1 here would become the subscript of the K. So the KCl actually become K1Cl1. But you know, in chemistry we don't write 1, so we can ignore the 1 to become KCl. So either way, you get the same formula for potassium chloride, which is KCl. Okay, this is the first example, potassium chloride. Now let's look at the second example. The second example is calcium fluoride. So same thing, you have to write down the formula, the symbol for the chemical calcium. So again, from the periodic table, calcium is Ca, fluoride is from the word fluorine, and fluorine is right here. It is F. Okay, so F. And again, in order to find out the chemical formula for the ionic compound, you need to know the charge of Ca and the charge of fluorine. Okay, what is the charge for Ca? Again, look it up in the periodic table. Ca is right here, and it is group 2. Group 2, the calcium ion would have a charge of 2 plus. So this is 2 plus here. Fluorine, what is the charge of fluorine ion? The charge of fluorine ion, fluorine is in group 7, and the charge is 1 minus. So you just put a minus, 1 minus here. And then after that, you can ask yourself, how do I balance the charges? 2 plus and 1 minus. Then of course, if you want to balance the charges, you need 2 of the fluorine of the fluoride ion, so becomes Ca2 plus CaF2. And alternatively, you can use the cross multiply. So the 1 will become the subscript of Ca, and the 2 will become the subscript of F. So it becomes Ca1F2. We don't write the 1. So either way, you get the formula for calcium fluoride. Okay, let's look at the third example. Third example is potassium sulfate. Now, what is the chemical formula for potassium sulfate? So potassium, you know already from example 1, potassium ion would have a charge of 1 plus because it is from group 1. Sulfate, now this is one of the 5 polyatomic ions that I asked you to remember, to memorize the formula. Sulfate is SO2 negative 4. Now how do you balance the charges? One is 1 plus, the other one is 2 minus. Obviously you need 2 of the potassium ion and you need 1 of the sulfate ion. So this would be the formula. Again, you can use the cross multiply way, and this 1 will become the subscript for sulfate, this 2 will become the subscript for K. So it is K2SO4. So either way, you get the correct formula for potassium sulfate. Now let's look at a more complicated example. This is ammonium carbonate. Now ammonium carbonate, this ammonium, again, this is one of the polyatomic ion that I asked you to memorize the formula. Ammonium, if you remember the formula of the ion, ammonium ion is actually NH4 and then 1 plus. Carbonate, again, is one of the polyatomic ions that I asked you to memorize the formula, and it is CO3 3 2 negative. Again, in order to balance it, obviously we need 2 of this NH4, because this is 1 plus, this is 2 minus, so we need 2 of this 1 plus to become 2 plus in order to balance the charges, in order to balance the 2 minus. So NH4 we need 2, because this NH4 is together, so we have to put a bracket and then put a 2 outside, and CO3. So this would be the formula. Again, if you want to use the cross multiply, you can just do it like this. So 2 is a subscript for NH4, this is this 2, and this 1 is the subscript for carbonate. There is a 1 here, but again we don't write the 1. Okay, let's look at the 5th example. The 5th example is calcium nitrate. Okay, calcium, from the second example, calcium, the ion is 2 plus because it is from group 2, so Ca2 plus. Nitrate, this is one of the 5 polyatomic ions which I asked you to memorize the formula. It is NO3 1 minus. Okay, this is 2 plus here, this is 1 minus. Obviously we need 2 of this 1 minus, so that it becomes 2 minus, and 2 minus would balance the 2 plus. So the formula is CaNO3 and then bracket 2, or you can use the cross multiply. I don't think I need to elaborate on that. Okay, and of course the last, no, actually this is the last example, is sodium hydroxide. Sodium is from your periodic table, it is Na. Hydroxide, this is one of the 5 polyatomic ions, is OH minus. Now Na, what is the charge for the sodium ion? Sodium is in group 1. Group 1, all the group 1 element will form the ions with a charge of 1 plus. So your Na is actually 1 plus, Na. Then after that, 1 plus, 1 minus, how do you balance it? Just NaOH. Or you can cross multiply. 1, 1. So NaOH, or Na1OH1, but we don't write the 1, so it's NaOH. Now you can actually download the worksheet and try to work out the formula for the chemical formula for the ionic compounds. And if you have questions, you can always look for me. That's all for this lesson, how to write chemical formula for ionic compounds.